Stanford University.
Okay, well, welcome to CS193P, Stanford CS193P. This is at developing applications for iOS, winter of 2017. Today, we're going to talk a little bit about what this class is about and the prerequisites you need. Then I'm really fast going to go over iOS and what's in it. And then I'm going to dive into a big, long demo. And this demo is going to really quickly let you see what it's like to develop an application for iOS, so you can decide, is this for me or not? So, what are you going to learn? Well, you're going to learn to build cool apps. All right, that's what we're here for. Why are these apps in iOS cool? For a number of reasons, okay? One is they're in your back pocket. You can pull them out and show your friends on your phone. A lot of them are networked, so they're kind of social apps, and a lot of that can be a lot of fun. Also, if you decide to turn your app into a product, it's really easy to get it out to your customers via the App Store. You don't have to wrap it in a box and put it on a shelf somewhere anymore. You can get it out there real quick. And also, you're going to see today even, it's really easy to build pretty complex apps pretty quickly. So you get a lot of instant gratification from building iOS apps. For those of you in computer science, there's also this huge benefit. You're going to get to see real-life object-oriented programming system. And not just object-oriented programming, but we're going to use databases in this class, and graphics, and multimedia, multi-threading, animation, networking, all these things. And you're going to see it in a real-world environment. So you take a lot of classes on all these subjects, and sometimes you get maybe a little disconnected from what's this like in the real world. Well, you're going to get to see it all in action here. Prerequisites, just boiling it down really easily, the prerequisites for a class is object-oriented programming. You have to know object-oriented programming. I'm not going to teach that in the class. I completely and utterly assume it. And not only do you have to know it, you have to have some experience doing it. So that's why here at Stanford, CS 106A and B are a hard prerequisite. You have to have taken those two. Those are object-oriented programming classes. And then I just want to make sure you have some programming experience. So either you've done something outside of school, or you've taken CS 107 or CS 108 or CS 110. CS 108 is a particularly great prerequisite. That's object-oriented programming. So if you have a chance to take CS 108 and you haven't taken it yet, maybe take it and then take this class the next time it's offered. All right. So let's dive through what's in iOS really quickly here. I've divided it here into 4 layers. These layers are roughly close to the hardware and then up close to the user. So that bottom layer close to the hardware, that's actually a Unix operating system. Okay? Just like Mac OS, iOS is a Unix operating system at the bottom. None of these APIs are object-oriented or anything. They're basically C, okay? Because Unix is pretty much written in C. These APIs are in C. We're going to do no work at that level in this class, okay? This is an object-oriented programming only class, so we're not going to be doing anything there. So there's another layer right on top of that called core services. Sometimes people refer to this as foundation, but there's other things in this layer besides foundation. And this is an object-oriented layer on top of those things that were lower down. Okay, so now you can do networking, file system, things like that using object-oriented API. But this is still non-UI layer, right? It's still kind of closer to the hardware. So I'll definitely be teaching you a lot of stuff at this layer because you just need it to do the things you're going to do. Now there's another layer here, the media layer I call it. This is a huge layer which has 3D graphics and audio playback and recording, image processing, video, all that stuff. Unfortunately, I'm not going to have a lot of time to spend here, even though it's a huge part of what an iOS device does. I mean, iOS devices all pretty much have iPods in them, video iPods if you want to think about it, and so there's a lot here. Unfortunately, I can't cover it all because I'm going to spend most of my time up here, which is the Cocoa Touch layer. This is where buttons and text fields and things are, but also much more powerful objects like maps. Okay, there's an object in Cocoa Touch, which is a map object. It's pretty much the entire Maps application on an iOS device that you can drop right into a rectangle in your app. Okay, with almost no work. So very powerful objects at this layer. This is where we're going to spend the vast majority of our time building user interface apps at this layer. Okay, that's a rough overview. Okay, trying to explain all of iOS in 2 minutes is pretty much impossible, but that's kind of what we're doing in this class. We're going to use all of these components to get our work done. Top level there, Xcode 8 is going to be everything we do is going to be in Xcode 8. The debugger, the editor, everything, the building, it's all in Xcode 8. There's a little app, instruments that goes along with it for performance and stuff, but pretty much it's all Xcode 8. 2, I'm going to teach you a new programming language. Okay? So if you're computer science people, you know that learning different programming languages is really valuable skill. Okay? Not because you're necessarily going to use all of them, some of you might not use, but just the process of seeing how language designers pick and choose their syntax and the feature set is really valuable. So you'll get that valuable thing. It's a great language. It was just invented in the last 2 or 3 years, so it kind of incorporates the best of a lot of different languages. So I'm going to kind of blitzkrieg teach that to you in the first couple weeks. Frameworks, that's essentially things like the Cocoa Touch UIKit framework is where all the buttons and stuff are. Foundation is that kind of mostly of that core services layer. But there's a lot of other ones like Core Data Framework, Object-Oriented Database. We'll be doing that in assignment 5. Also, I talked about that map thing. That's in a framework called MapKit. And there's also things in Core Motion like the accelerometer and the gyro in the device. All those things. I'm going to be teaching you many, many of these frameworks as we go on. And last, but definitely not least, very, very important, is a design strategy for how to build apps. It's called MVC, Model View Controller. How many people already know MVC, have learned in a different class? See, so maybe half of you. I will spend the first part of Wednesday's lecture telling you about MVC and what it is. We 100.0% have to use MVC when we develop apps for iOS. There's really no other way to do it. If you do it any other way, you're swimming so upstream against the current of iOS, you'll end up with a mess of an application, okay? So we'll be going over that as well. This demo that I'm going to do, we're going to build a calculator. Okay, calculator is great because it's got a fairly simple UI, but it's got a little bit of guts on the inside, the actual calculating part. So it's just complicated enough to start showing you MVC and a lot of language features and things like that, but not so complicated that I can't do an entire calculator, basically, in 2 lectures, okay, start to finish. All these topics up here, you don't have to look at them now. This is a slide to go look at after my lecture today and say, did I learn that? Yeah, I think I got that. So it's kind of a summary of what I'm going to do. Since I'm not going to get back to the slides from the end of my demo, it's just going to be the end of the lecture, I'll tell you a little bit what's coming up. On Wednesday, I'll be continuing this demo, but not until after I give you this talk about MVC, because what we're going to do in the calculator is apply MVC to it on Wednesday. And your first programming assignment will go out on Wednesday, which is pretty much to replicate what I'm doing today and on Wednesday. Okay? And I'll give you a video of the demo, so you'll see it, and you'll be able to watch it. And then on Friday, we have an optional section. So the Friday sections in this course, you don't have to go to if you don't want to, but a lot of times they're very valuable features. So if you have not used the debugger in Xcode 8, you really might want to go to Friday's lecture. The location and time of it will be posted on the class forums, hopefully tomorrow. I've asked for the room and haven't quite got it yet, so hopefully tomorrow. And then don't forget, next Monday is a holiday, so we're not meeting on Monday. Our next class after this Wednesday will be next Wednesday. So let's hop into the demo. So I said we were going to build a calculator. Let me actually show you a calculator. This is the Mac OS calculator. And our calculator is going to look very similar to this, right? It has a display along the top. It has a keypad for typing numbers in. And then it's got these operation buttons, right? And you multiply times 8, you hit equals, it does the operation. That's pretty much what our calculator is going to do. It's not going to look exactly like this. It's going to have a look that's a little more appropriate for an iOS device, but it's generally this. And I promised that Xcode would be your one-stop shop for doing all the development, so we're going to spend our entire time here working in Xcode. Now, Xcode is an app that you just go to the Mac App Store and you download it. It's free. Okay? When you first launch it, it's going to put up this splash screen like you see right here. And all of your projects are going to start accumulating here over on this right side where this gray area is. And you can basically do three things here. You can use a playground, which I'll show the playgrounds on Wednesday. It's kind of a little play area for iOS programming. You can check an existing project out of a source code control management system, which we're not going to be doing, although we'll probably have a Friday section on doing source code control. So we're going to be doing this option right here, create a new Xcode project. And in fact, when I do demos in this course, I almost always start from scratch. because I don't want you to have to like come up to speed on some code that I give you first and then learn from there. So we try to start from scratch and see what we can do that way. So I'm going to click on this to start a new app. It's asking what kind of app do we want to build or what kind of project. And here you can see we can do watch apps, Apple TV apps, even Mac OS apps. But we are doing iOS. And in fact, we're always going to choose this single view application template. It's the simplest template. And some of these other templates have code in there that I actually want to show you how to write yourself instead of having the template just make that code appear. All right. So we're going to do single view application. Now it wants some particulars on our application. Most importantly at the top, its name. Well, we're building a calculator, so we're going to call this calculator. Okay, that's going to be the name of our app. Now this second line here, team, that's the team of developers who are going to work on this project. That's going to be a team of one, which is you. Okay? When you launch Xcode, this is probably not going to be a pull-down list. It's going to be a button that says add account or something like that, add team. You click on that. All you'll need is an Apple ID. Any Apple ID will do. It won't cost you any money. And it won't go through the dialog there, and it'll create a team for you. And then you use that here. All right? This organization name can be anything you want. It's just going to appear on the copyright symbol at the top of your source code files. That's it. But this one, it's super important that this be a unique identifier of you. Okay? So I strongly recommend doing edu.stanford.cs193p.your SUNet ID here. Okay? If you put that in there, you're almost guaranteed, if you're a Stanford student, for that to be unique. If you're not a Stanford student, you're watching this on iTunes U, pick something else that uniquely identifies you. Hopefully, reverse DNS notation will work in your circumstance as well. The language we're going to use, like I said, is Swift. iOS was originally written in a different language called Objective-C. Turns out you can use Objective-C and Swift in the same application. Okay? They use the exact same underlying iOS API. So everything you're going to learn in this class in Swift, if you later went and learned in Objective-C, all that learning would be valid. Okay? Because in fact, it's the exact same code base. It's not just the same API. Swift was designed in a way to be quite compatible with Objective-C's APIs, and in the last couple of years, they've even enhanced Objective-C to catch up with some of the advanced stuff that Swift does. Our app that we're going to build, our calculator, is going to be universal. That means it's going to run on iPhone and on iPad. Okay? First couple weeks, it'll be iPhone only, but then eventually we'll add iPad support as well. We're not going to be using a database in the calculator, but we will in your assignment 5. And when it comes to testing, which is super important, again, I'm hoping to have a Friday section to tell you a lot about testing, especially the UI testing framework is really awesome. Okay, so hopefully we'll get a chance to show you that. So I'm just going to click Next here to create my app. It says, where do you want to put this project? I recommend you put it home directory in a folder called Developer. Okay, then all your apps will just pile up in here. This is pretty much a canonical place to put it, so I strongly recommend it. And then again, source control is more for teams working on it. You're going to be working this by yourself, so you can leave this switched off. All right, there you go. There's your first iOS app. Okay. Now let me explain a little bit about Xcode and how it's laid out here. So that if you haven't seen it, how many people have worked in Xcode before? See, so again, probably half of you, so quite a few. For those of you who haven't, it's divided into these 3 main sections here. This main section in the middle, this section is the primary place you're going to do all your source code editing and things like that. That's where you do most of your work. This section over here on the left, this blue section, is called the navigator. You use it to navigate your project. And here you're seeing it in a file-based view, where I'm looking at all my files, and we'll look at those in a second. But you can navigate by searching. Okay, it's a search panel. If you're debugging, you can navigate through all the breakpoints that you have, etc. So you'll learn all about the different ways that you can navigate as the quarter goes on. On the right-hand side here, you see this little area. This is called the utilities window, and I'm going to talk all about this in about 5 minutes. Okay, we're going to use this in great detail. I want to show you a little bit how you can manage your space here. If you look in the upper right, you see these buttons here. You can click this one over here to hide and show that utilities window, and same thing over here for the navigator, so I can make more space for you. All right, and also there's another one here, this middle, that hides something from the bottom. Okay, this is your debugger window on the left, and your console, which is just a place where you can log strings out to while you're debugging, on the right. And we'll see that in a moment as well. All right, so let's go look at these files, right? We're in the file navigator here on the left, and there's 6 files here, but 4 of them are really just supporting files, and we're not even going to look at them in the calculator. We'll look at a couple of them as the quarter goes on, but they're not primary files. And for example, this one, assets.xc assets, Xcode assets. This is images and videos that might be embedded in your app. Here you can see this is the app icon. I haven't set any of my app icons. You can see there's a lot of different resolutions of them. But this XC assets and the launch screen and this info.plist and this app delegate right here. By the way, I'm holding down command. You see in the lower left, you can see any command keys that I press. Right down there, because I'm going to use command keys for various things that we do. So I use command to select all these, and then it's going to right-click and go down to here, new group from selection, and it's going to put these 4 files into their own little folder. There, it did it. I'm going to call it supporting files, okay? And I can move these around in the navigator. See, there they are, hidden in there. We're not going to look at those. We're going to focus on these 2 files right here, okay? This file is your first look at Swift. Here it is. It's got some very important methods right here, which I'm going to delete. Okay, they're important, but the fact that I delete them doesn't make them not important. It's just that I'm not going to teach you about them for another couple weeks, so we're not going to use them in the calculator. And in fact, I'm going to go into detail about this Swift code more in a moment. But before I do that, I want to focus on this file right here, main.storyboard. This is your user interface. This is your calculator's user interface. And one thing you notice when I click on that, there's no code here. Okay? When you build your user interface in iOS app in Xcode, you do not write code. Okay? We're just going to build it with the mouse. We're going to drag some things out. We're going to use some inspectors to set the objects we want the way we want them. That's how we're going to build our UI. That code that you saw, that is only going to control the behavior of the UI. What happens when you touch on a button, things like that. That's what's going to be controlled by that code. But the actual layout of all the buttons and all that stuff is going to be done here in this graphical view. Now you can see there's this area here on the left. Okay, this is called the document outline. If you're down here, you'll see a little button there, the document outline. The document outline has all the things in the user interface in an outline form. And that's going to be very useful for us later in the quarter. So I'm going to hide that. That's what this little button down here is. It hides and shows it. We're going to hide that to make more space. We're not going to use that in the calculator either. So that leaves this space here. And if I zoom in a little bit here, or zoom out rather, you can see I start to see something that looks like an iPhone. Okay, it's kind of iPhone shaped. I can also, by the way, hold down the Option key and use my mouse wheel to zoom in and out here. Okay, so this looks like an iPhone. In particular, it looks like an iPhone 7. You see down here at the bottom, it says View as iPhone 7, right? And if I click on that, View as iPhone 7, you'll see all the other iOS devices appear. Okay, iPads, for example, or old iPhone 4s that are really kind of little. And not only are they there, but you can switch their orientation. Okay, now when you build an iOS app, you want the UI to look good on all these devices. And you don't want to have to write a lot of special if-then code all over the place to make them work. So this whole system of building your UI, which by the way is called Interface Builder, this part of Xcode is called Interface Builder, is oriented with a lot of functionality to make it so you can build your UI once and it'll work on all these devices. Okay? Now, I'm not going to actually start doing that until the end of the lecture on Wednesday. So for now, we're just going to build our UI. It's going to be kind of a mess. We'll throw our buttons anywhere we want. We're not really worry about working in landscape mode like this versus portrait or a small device or a large device. Okay, we're not going to worry about that right off the bat. But I just want to preview the fact that we are eventually going to build this universal UI that works on all of them. So here's our iPhone 7. We want to start building our UI. We need some UI. What do we need? We need buttons, and we need kind of a display across the top. Let's start with the buttons. Where do we get these buttons? Well, as promised, I'm going to talk about this utilities area right here. Now, this utilities area has a top and a bottom. You see that? And in the bottom, right here, under this region called the object library, is a library of iOS objects that you can build your app out of. And it has things like buttons, text fields. It has more complicated things like image views and text views, which are multi-line editable text. And it even has things like that map thing I was telling you about, or a web view, which is basically Safari in a little rectangle. So it's got a lot of powerful things, and there's a lot of them in here. And we will try to cover the vast majority of these in the course of the quarter, but it's almost really too much to cover. So we're going to start, though, simple with a button. And if I want a button in my UI, I just pick it up with the mouse, okay, and drag it in. Now, when I drag it in, see these blue lines are trying to help me put it in a good spot. You see that? Now, we're not going to pay attention to that right now because I told you we're not doing this thing where we're building the app that'll work on all devices. But when we start thinking about putting it on an app that works on all devices, we really want to use these dashed blue lines. Okay? Because if you say something like, I want this to be in the center, well, now it'll be on the center on every device, no matter what the size of the screen, you see? So these blue lines help you communicate that to Interface Builder that you want it in the exact center. So again, we're not going to worry about that for now, so I'm just going to drop this in the middle of nowhere. But again, those blue lines are going to be very important down the road. All right, so we got this button here. It's not a very good button because it's not kind of small, and it says button on it, and we want it to be, let's say, one of our number buttons. Okay, so how are we going to do that? Well, we can double click on it and type one of our numbers. So I'll make this be my 7 button. So this is going to be my 7 button on my calculator. And I can resize it. You see when I select it, I get these handles, so I can just pick it up by a corner and resize it. And when I do, it even tells me exactly what size. So let's pick maybe a size like 64 by 64. That's a pretty good computer science size. It can be a little tricky to do it there. Oh, there we go. Okay, so we got 64 by 64. Now, actually, this size is not even going to matter in the long term because on a smaller device like an iPhone 4, it's going to be shrunk down, and on other devices, it can be shrunk out. But for now, we'll pick something that's kind of using a reasonable amount of the screen real estate on an iPhone 7. This is still kind of a small 7. We want it larger. So when we want to do things like that, that's where we go to the top half. I'm just going to get rid of this bottom half by scrolling it down here. We're going to the top half of this utilities pane. And this is inspector. And there's different kinds of inspectors. We're going to be using the attribute inspector here. But there's also, for example, a size inspector. When I click on that, you see that there's the 64 by 64. I could have just typed it in instead of trying to get it exactly on there, okay? The attributes inspector is kind of an object-oriented inspector. You can see that it knows a button is selected, so it's showing you button things that you can set about a button. But a button is a class, object-oriented class, that inherits from control, so you're seeing control things, and that inherits from view, so you're seeing view things. Okay, so this inspector is object-oriented. It shows you all the things that can be inspected about this object, even using inheritance. So if I want to change something like the font, I just look down here, type title. Oh, here it is, font right here. I'm going to click on this, and I'm going to change this to 30 point, let's say. Okay, that looks pretty good. Now, maybe I want to have a background for this button. So if I look in here, there's background image. I don't want a background image. I actually want a background color. So there's nothing in button that does that. But if I go down to view, I can see background right here that's a color. And if I click on this, I can pick a color, one of these predefined colors or other colors. Let me choose from color picker, a little crayon box or whatever. So I'm just going to pick from here the light gray. That looks like a good background color. So now I've got a button. Okay, here's a nice button. And in fact, we could even see what our app looks like just with one button. Now, when it comes to running, the way you decide where you want to run your program, because you can run it on a device or you can actually run it in a simulator. Okay, and for the first few weeks in this class, you can use a simulator. Towards the end of the class, I'm going to ask you to start running on your device, so you get used to doing that as well. But the way you do that is you go up here. You see it says Calculator iPhone 7 Plus. If you click on that, you'll see a whole bunch of simulators. These are all simulators of all those different devices that can run iOS 10. And then right up at the top here, you could pick, if you had an actual device connected to your Mac, you could pick a physical device. And I'll be showing you that in a couple weeks as well. So let's run it on iPhone 7. Okay, so I just picked iPhone 7. And I'm going to press this little play button right here to run it. Okay, now it's going to launch the simulator. Now that simulator is a full iPhone simulator. So it's not just running our app in a window. Let's go find it here. It's over here. And it's kind of big here. We'll make it smaller in a second. So this, in fact, there it is. You can see it's zoomed in. Now, the iPhone 7 has very high resolution, and I'm running on a small resolution screen. But you can actually go down here to scale and scale it down a bit. Yeah, maybe that's too much. Let's scale it to here. Yeah. So we're seeing 50% size here of an iPhone 7. And there's our 7 button right there. Okay, now you can press the home button on this iPhone 7 by going to Hardware, Home. And when you do that, look, this looks just like an iPhone. You've got settings. You can go in and set some settings. Okay, do Home again. Command-Shift-H is Home. And then you can go back to your app, which is the calculator right here. Okay, so if you're writing an app, for example, that uses GPS, and you need to go to the settings to enable GPS location, you can do that here on your simulator. Okay? All right, so we got the 7 button. Let's click it. Okay, well, it's flashing, so it looks like it's working, but of course it's not doing anything. We haven't told our 7 button what to do, so it's doing nothing. All right? So let's go make it do something. Now, I told you that the behavior of the UI is written in code. So that's what this guy over here is, this viewController.swift. That's the code where we're going to do the behavior. And so how do we hook up this UI to this code? Well, to do that, we need to get them both on screen at the same time. All right? And the way we do that is with this button right here, the Assistant Editor button. So I'm going to click it, and we get both. And I can click, for example, on one side to show my UI, and it's automatically going to show the code on the other side. Okay, because it knows that I probably want to do that. And it does that because up here at the top, you see it says automatic. It's automatically picking it. Now, you can go to manual and manually pick the file you want to appear here, but most of the time you're going to leave this on automatic, and it's going to pick automatically the thing that makes the most sense to be on the right-hand side. Okay, we'll make some more space there. All right, so let's zoom this in a little bit so we can see the whole iPhone 7. All right, so let's look at this code first, because this is the first time you've seen Swift. Swift is really nice because it's very succinct and kind of very obvious in the keywords it's chosen, etc. So import is like include in a lot of languages. It's just basically saying, I want to use this framework UIKit. Now, this is our UI behavior controlling code, so of course it needs to use UIKit. Okay? If we were to write an object that's more of like the internals of the calculator that's UI independent, then we would probably import Foundation here. Foundation kind of gets at that core services layer, non-UI. You would never want to import UIKit in one of those non-UI kind of classes. And you'll see that when we do the MVC on Wednesday. There's, of course, other things we can import too, like MapKit, things like that. All right, so here you're seeing your first declaration of a Swift class. Okay? Keyword class, of course. Name. This is the name of the class. ViewController is name of class is kind of a generic name. I probably would have given it a better name if I had had a chance, but this is what the template gave me. You can't, unfortunately, just rename this by typing because it's linked up to your UI. I will show you how to rename this class later, but for now we're going to stick with this generic name. This colon UI ViewController is the class that ViewController inherits from. Okay, this is object-oriented programming. This is inheritance. Again, you have to know object-oriented programming to be sitting in this room, so you know what that means. Swift is single inheritance, so you can only inherit from one class. And ViewController inherits from this class. This class's capabilities are it knows how to control a UI. That's why it's called a ViewController. We call this our view over here, and it knows how to control it. So this ViewController is inheriting all the capability of how to control this, which is great because that's exactly what we want it to do. And then inside the curly braces, here we're going to put all of our instance variables and methods. Okay, hopefully everyone knows what an instance variable and a method is, right? An instance variable is like storage variables inside of our class, and a method is just a function in there. By the way, we call instance variables in Swift properties. So if you hear me saying properties, I mean like instance variables. Okay, we call methods methods. All right, so what I really want now is when this button is touched, I want it to invoke a method. in my class, right? I wanted to call a method. That would be perfect, because then I can put whatever code I want in there. And that's exactly what we're going to do. Now, the way we link that up is kind of kooky. Here we go. I'm going to hold down Control. You see I'm holding Control down there. I'm going to drag from this button into my code. Okay? This is how I'm going to connect it. And when I let go, it says, oh, you want to make a connection between your UI and this code. What kind of connection do you want? And there's really two choices. There's outlet. That means make a property or an instance variable that points to this thing so I can talk to it. And then there's action, which means make a method. And when the buttons touch, call this method. Everybody got that? All right, so here it's asking for the name of this method. I'm going to call this method touchDigit. Okay, touchDigit. And this method, it can have arguments. It could have no arguments, or one argument, which is the button sending me this message. Now, I need that argument because I want to have one touchDigit method that all my buttons send. And so I'm going to ask the button who's sending it to me, who are you? Okay, what title? Are you the 7 button? Are you the 5 button? What are you? So I want that sender. This type right here says any. That's the type of the argument. Okay, wake up if you're taking a nap right now. When you're doing your homework, you cannot leave this to any, because we know what kind of thing is sending this message. It's a UI button. So you're going to want to change this any to UI button. If you miss that step, then when you go in there, your code's all going to be messed up, because the argument type of this sender is going to be any, which it just basically means untyped almost. So that's no good. So make sure you change this to UI button. Now, when we connect this, it creates a method. So you're getting your first look right here at a Swift method. Now, this is actually not part of Swift. Okay, this is something Xcode drops in there. And it does it so that it can put this little circle in the gutter. You see that circle right there? If I mouse over that circle, look what happens. I didn't click on it. I just put my mouse over it. You see, it tells me what this method is hooked up to. In other words, what user interface element sends me this message. Okay? So this is purely not a Swift thing. This is purely an Xcode thing. So this is a Swift method. Okay? So let's look at the parts of a Swift method, the syntax of it, so you understand a little better. And I'm going to use a different method that I'm just going to make up for this. Let's say I had some function called draw horizontal line, and it draws from some starting position, which would be a double, to some ending position, which would also be a double, and maybe it does it using some color, which would be a UI color. Okay? So there's an example of a Swift method. Notice that this has 3 parameters. You see? This one, and this one. This colon double is the type of this parameter. So it's a double precision floating point number. That's the type of that parameter. This one's also double. This one is a UI color, okay, which is a different type. Now, what's really interesting about parameters is that you have 2 names for each one. See, from start X to end X using a color. Each one has 2. So what the heck is going on there with those 2? Well, this one, the first one, is the external name of this parameter, and this is the internal name. So these internal names, like start X, end X, and color, you would use those in your code inside this method, like I might say distance equals end X minus start X, or something like that. See, I'm using end X and start X inside this method, okay, part of its implementation. These external names are used by the callers, the people who call this method. So I'm going to call this method from touchDigit here, draw horizontal line. Now, by the way, Xcode loves to type for you. So I just typed draw H, and now I'm hitting tab, and it's not only filling out draw horizontal line, but it's showing me all the arguments and tabbing to the first one so I can type it. So notice that when it said that, the from, the to, and the using were put in there for me. So if I say from 5.0 to 8.5 using the color UI color dot blue, let's say, okay, these from and to and using are what the caller uses. Notice also that these things are mandatory. They have to go in here. You cannot call draw horizontal line like this. Draw horizontal line 5.0. This would look like most other languages. blue. You can't call it like that. You have to put these external names in there. Also notice that the external names are picked so this reads like English. Draw a horizontal line from 5.0 to 8.5 using blue. Okay? Swift endeavors to be as kind of conversational in the language of English as it can be. Okay? So that's kind of the crash course. You're going to be reading, your reading assignment is going to tell you more about that, but that's the crash course. But now let's take a look at this. Oh, by the way, if your function returns something, you just go like this. Okay? Arrow, string. It's kind of like the arrow is saying, out of this comes a string. Okay? So this would be the return value. Okay? All right, now let's look at touch digit though. Touch digit is weird. Look at its two things here. Okay? The external one is underbar. Okay? Does that mean I call it by saying touch digit, open parentheses, underbar, colon, whatever? No. Underbar means there is no external. So you would call touch digit by just saying touch digit, some button, because that's the argument, it's a button or whatever. Okay? There's no, you don't put anything in here. It's not like a foo. If we had this, it would be foo. Okay? That's not in there. Instead, it's this underbar, so you have nothing. Okay? Now, why do we sometimes have nothing? Because sometimes it's implicit in either the name of the function or the type of the argument what you're supposed to pass, so you don't need that little thing. By the way, underbar, we almost never use that for the second, third, or fourth argument. It's occasionally used for the first argument, not always, occasionally, but never for second, third, fourth, fifth, okay, or next to never. Now, in your reading assignment, I'm also going to have you read a document that explains how to do this naming, what the rules are, when to use an underbar, when don't you. You're going to want to master that document by the end of the quarter if you want to call yourself a professional iOS developer, okay? It's key to understand that. But this touch digit, okay, so this function, okay, methods, just to be clear, methods, we use the keyword func, okay, because it's a function on a class. This is the name. Parameters go in parentheses like this. They can be separated by commas if we have multiple of them. This is the first parameter here, the first and only. Its type is a UI button, because of course a UI button is sending this method, right? It's invoking this method, so the sender is this UI button. And sender is the internal name, so that's the name we'll use inside here to access it. All right? But before we start doing that, let's just have this do something simple, like print out to the console. So I'm going to say print touch digit was called. Okay? We're just going to print that on the console. Whenever someone touches a button, it's going to invoke this method. It's going to print that on the console. So let's just do that. All right, so here's our UI, iPhone 7. Click, and touch digit appears in the console down here at the bottom. Okay? Now the console shares space with the debugger. This area on the left is the debugger. So you can kind of separate the space back and forth. You can also completely hide the space by using these buttons right here. Okay? So we'll just do console only right here. Let's go back to our simulator. And so every time we press this, we get touch digit was called printed out again. So everyone understand what's happening here, how we've hooked up this method to the button? Really, really straightforward. All right, now that we have that working, we know we need more than just this one button. We need a whole keypad worth of buttons. So I want these other buttons to look exactly the same, so I'm going to copy and paste. So I just copied and pasted that, paste another one here. I can even select 3 at a time and copy and paste. Okay, paste another one. Now notice here I'm using the blue lines to line them up. Okay, really nicely. Blue lines are great for doing that. Okay, and now I can just rename these buttons by just double-clicking on them. All right, so I've got a beautiful keypad right here. And what's really great is that this method is hooked up to all of them. Okay? That's because when you copy and paste a button, it keeps its connections to any methods that it has. Okay? So that's cool. So now all these buttons are going to send this touch digit. So now if I run, you'll see that if I press any of these buttons, not just our 7 button, right? Here's 7, that worked, but also 5, 0, they're all calling this touch digit was called. Okay, so that's awesome. But of course, we want to know which button was sending us this message, right? And we know that because that's the argument, is the sender. Okay, so let's add a local variable here. So now you're seeing your local variables in Swift for the first time. It looks like this, var digit. Okay, var means this is a local variable, digit is the name. Now, if we wanted to type it, we could put a type here, like maybe type string. Okay, just like we put a type of our parameter here, we can put a type right here of our local variable. But we don't usually do that in Swift because while Swift is very strongly typed language, in other words, you have to specify the types of everything, it wants to know the types of everything, it will infer what type you want from the context very often. Okay, so that's the trade-off. If you have a really strongly typed language, you have to really give types to everything. It's really nice if the compiler will just figure out for you what the types of thing are. So normally we will leave the types off wherever we can. Now we can't do that in a method parameter because we've got to know what that method is expecting. But for local variables, we definitely can leave it off almost all the time. Okay? So we got this digit. I just want to set it equal to something. What does it want to be equal to? It wants to be equal to the title of the button that's sending me the message. So this guy, which is a button, I want to ask what its title is. Now, how do you send a message to another object in Swift? Well, you just type the object you want to send the message to, and you press dot. Okay, so this is like Java and a lot of other languages, just the object and dot. That's how you send the message. Now, unfortunately, Xcode is helping me here by showing me all the methods and properties that button can do. Look at this list. I'm only in the F's. Okay, I'm still scrolling, still scrolling. There's a lot of methods. Way too. It's like, how am I ever going to figure out? I just want the title of the button, please. Okay, well, of course, I could get the documentation, start reading through it, try to figure out. And in fact, I want to do that eventually. But there's kind of a trick here in Xcode, which is just type the name of the thing you want. Type what you think it might be and see what happens. So I'm just going to type title. Okay, now there's no method or property in button called title. But you can see that Xcode has showed me all the methods and properties that start with the word title, or that have the word title in it, or even that have T-I-T-L-E in it, okay? So it's doing everything it can to show you every possible thing that might match what you typed. Now, let's look through these and see if we can find one that will give us the title of the button, okay? Title label, that doesn't look very good. How about this? Oh, title for control state, that looks good. Returns the title associated with the specified state. That looks pretty good, but let's keep looking because I don't really know anything about this state. I don't know what that means, button state. So let's keep going. Edge insets, no. Color, no. Shadow, rect, no. Current title, the current title that is displayed on the button. Woo, victory, that sounds exactly what I want. So I'm just going to pick that by double-click on it. So I'm just going to double-click on it. There it is, it filled it out. And so now we're sending current title to sender. Now let's find out more about current title. Okay, we know that one-liner that it's the current title displayed. I'm going to hold down Option. See Option down here on the left? Okay, I'm going to hold down Option, and look, when I do Option, things that I mouse over turn blue with a little dashed underline, and if I click, I get a little help. Okay, so I'm getting that current title displayed on the button, but I'm also getting a more detailed description, and I'm getting the declaration of this thing. And you can see that this is not a func, this is a var. So now you're seeing for the first time the declaration of a property in Swift, okay, an instance variable. So this is an instance variable in UI button, okay, called var, makes sense, right? It's a variable var. It's called current title, of course. Its type is string? Not sure, maybe button's not sure what the type is. No, I think button knows, but we're just going to assume this is string for now, and we'll see where that takes us. Also notice this little syntax means that you can only get the current title with this property. You can't set the current title. Now, what if I was like, oh, well, I'm interested. How would I set the current title? So you would want to, let's say, go look in the documentation. How would you get there? Well, if you look down at the bottom, it says more, this property reference right here. If you click on that, it brings up the documentation. Okay? And here's the documentation for current title. Now, what's cool about this is from here, I can click on things like string. I can find out about string. Or look, I can click on the class that this is defined in, UI button. And here's UI button. And look at this section at the start of UI button called Overview. These are awesome, and I strongly recommend every class you go to use, take the 5 minutes or 10 minutes at the most to read through these overview. Then you'll really understand how these classes work. Look at this thing. It tells us, for example, how to configure the button's appearance. It tells us all about this button state. Remember we had that title for state and we didn't really know what state was? Well, this tells us about that. It tells you about the content of a button. You can put an image on there evidently and text. Those edge insets, whatever those are explained. Even in Interface Builder, all those things in the inspector. Look, those are all explained in detail. So this is a great thing to just read through this, understand this for all the common classes. And of course, all of the methods are listed here as well. For example, look at this one, set title. That might be a way to set the title. And if I click on that, I get a full description of this. And I even see that it's this state thing is here, so I could click on that. And now I see the control state. Oh, of course, there's normal, highlighted button, disabled button, a selected button. They can each have their own title. Cool. Okay, but you see how I'm navigating by just clicking through the various types and all that? You really want to get facile with doing that. Okay, it's really important to be a good iOS developer to be able to use the documentation effectively. All right, so we're back here. We got this thing CurrentTitle. It's this type string question mark. And I told you that Swift would infer the type. And sure enough, look at digit. Its type is string question mark. Of course, because I just set it equal to something that was string question mark. So it knows it's string question mark. So let's go ahead and print this digit out. Okay, same touch digit was called. Let's try and print it out. Now, in another language, you might use printf. And you might say something like %s was touched. And then you would put digit right here, okay? Now, unfortunately, you can't do this in Swift, okay? There's no %s business, okay, and no printf. Instead, we still say print, okay? But instead of doing %s, we can actually use the very magical / open parentheses, close parentheses. If you put that inside a string, then you can put anything you want inside there that can be converted to a string, and it will include it there, including a string itself can obviously be converted to a string. So this way you can embed strings in other strings, or even embed more complicated objects that know how to turn themselves into a string into strings. Okay, so this is how you do the printf business, or printing things out. Okay, now also I notice we have a warning. This yellow thing is a warning, okay? And they can be yellow, which are warnings, in which case it'll compile and run, but you still got to fix it because you cannot submit any homework in this class with warnings. You hear me? Or they could be red. In red's case, it won't even build. So this one's yellow. How do we find out what it is? Well, we just click on it. And when we click on it, it says here, the variable digit was never mutated. It means it was never changed. Consider changing to let constant, it says. Okay? And you can see it even saying, you want me to fix it? I can replace var with let. And it's even showing what that would look like to replace var with let. How helpful of it. So actually, I'm going to have it do that. Double click, woo, change it to let, warning gone. Now, what is all that about? Okay? It said that digit was never mutated. It was never changed. Okay? So digit essentially was a constant. We gave it an initial value. It never got changed. When you declare a constant, you always want to use let. Now, why do we have a different word for a constant than for a var? Okay? Well, because a constant isn't var. It doesn't vary. A constant is constant. And let is a great word because read this. Let digit equal sender's current title. Okay? Reads really nice. Now, why do we care about distinguishing these two? Two reasons. One, if you're a reader of someone's code and you see let, you know that this is not going to change. Okay? You know the digit is going to be never going to change. And in fact, if someone did change it, or if you tried to change someone else's code and change it, the compiler's going to generate an error. Okay? You can't change something that's constant. But even more importantly, it tells Swift that it's a constant and that you intend it to be a constant. And so later, if you try to modify it, even if it's an array or a dictionary and you're trying to put something in the array, okay, or add something to the dictionary, it knows, oh, you intended that to be a constant, so, error. So it's a way to tell Swift what you intend. Now, the difference between a mutable array, an array that you can add stuff to, and an immutable one is huge. Because if arrays in Swift are passed around by copy, Okay? Arrays are passed by copy. It's very unusual compared to other languages where an array would just be an object in the heap and you just pass a pointer to it. You were passing them, it copies them every time you pass them to a function. Now, that'd be very inefficient if they were all mutable, because you'd have to actually copy them in case someone changed it. But Swift knows which ones are mutable and which aren't, and when you pass an immutable one, it only does a really efficient copy. Okay, it doesn't actually copy the elements. And in fact, until you assign it to a mutable variable by saying var equals that, it doesn't even have to worry about that. And then it can just do copy on write when you actually change it. Okay, so that's the var let thing. Get used to it. Always do let for constants. All right, so let's run this now. See what's going on here. This should work, right? We're getting the current title. We're saying whatever that title was touched. This should be good to go. Here we go. 7. Oh, what? Okay, well, it's kind of working. I mean, it's definitely doing something different, and it kind of knows which button. But what's all this optional quote business? What's that about? Well, that's because digit is not a string. It's a string question mark. Okay, so what is string question mark? String question mark is a totally different type from string. It's called an optional. All right, this is super important. So again, wake up if you're napping. Okay, this is super important. Very few languages have this concept. It's a great concept. It really makes the API really understandable throughout all of iOS, but it takes a little bit of getting used to. Okay, so what is this type optional? A type optional has only two values, set and not set. Okay, that's the only two values it has. There's no other values. However, when it's in the set case, it can have an associated value. Okay, a value that it kind of keeps on the side. And you specify, when you create the optional, or you declare it, what type that associated value is. So this, the associated value, is a string. We're talking about the title of a button, of course. So we would say that the type of this digit is optional string, which means an optional whose associated value in the set state is string. Okay? Now, in this case, that's all fine and good, but we want the associated value here. Give me that associated value, that title. Okay? How do I get it out of here? And the answer for that is exclamation point. Okay? If you put the exclamation point on the end of an optional, then it will, if it's in the set state, grab the associated value and give it to you. So now look at the type of digit. Woo! It's a string. Okay? Swift was able to infer that since you unwrapped this optional right here, you've got a string over here. Now, what if you do exclamation point and that optional is in the not set state? Because there's no associated value when it's in not state. That's only when it's in associated. What happens to your app? Anyone want to guess what happens? Crashes. Okay? Kaboom. Now, I'm sure some of you conservative folk out there are like, okay, well, that's it for me, an exclamation point. I'm never using that. I don't want my app to crash. That's horrible. But actually, having your app crash during development can be great because you'll find bugs really fast and you'll be dropped right in the debugger where the crash happened so you can figure what's going on. How could this have happened? So in this case, we're talking about the title of a button. That means the title of the button was never set, and this is touch digit. That should never happen. Okay, if that happened in something I shipped to my customer, customers will be complaining left, right, and center. There's a button that has no title on it, nothing on it, and I click it. What, you know what I'm saying? So you want to find those in development. So crashing can be good sometimes. Now, of course, you don't always want to crash when you unwrap an optional, and I'll show you in a little bit how to unwrap an optional and get its associated value, but test it first to make sure that it's in the set state. Okay? But for now, we do this. Let's run and see what this looks like. Should work. Now we've unwrapped this thing and grabbed its associated value, and we know the current title should always be set, so we're not have to worry about crashing here. And sure enough, 7 was touched, 9, whatever, 3, 5, 6. Okay? All right, so we're rocking and rolling here. We're able to collect the digits from user. Now let's put them in the calculator's display. So we need to add a display to our calculator. So we're going to go back to our area here, go down to the bottom half. Now be careful not to grab text field here because that's editable text. And in a calculator, you can't click on the display and edit it. You type the numbers to put your numbers in. So we're going to use this one up here. which is label. By the way, if you click on one of these and leave your mouse there for a second, it'll give you a detailed explanation of each of these objects in the list. So I'm just going to pick out a label and drag it up here to top, maybe make a little more space for it, move out a little bit. So we got this label. Once again, just like I did for the buttons, I want to change the size. Maybe I want to start with 0 in there, bigger font. Let's go over here, maybe even really big font, like 40 or something like that. In a calculator, the text is right aligned, right? Text comes out from the right, so we want to use this alignment right here, right aligned. Okay? Maybe with some colors, let's make the background be blue. But I don't really like black on blue, so we'll go up here and change the color to be white. Okay, so that's a pretty decent looking display right there for now, anyway. Now, if we have these buttons being pressed, we need to talk to this display and tell it what the digits are. So how are we going to do that? Well, again, we need to make a connection between that display and our code. But this is not the same kind of connection because we don't touch on that label and it calls a method. We need to have an instance variable or property that points to that thing so we can talk to it whenever we want because we've got to put these digits on it. Okay? So we're still going to use the same mechanism to make a connection, which is control. And we're going to drag in here. Okay? And this time we're going to use outlet. Outlet means a property that points to this. And I'm going to call this display. It's our display. It got the type right here. This weak and strong, don't worry about that. I'm going to talk about that next week. Okay, so just don't worry. So here is our first instance variable in our class. Woohoo! Okay, this right here is, again, just some stuff that Xcode throws in there so you get this, right? This, I told you ignore. Okay, so this is the declaration of our property. And of course, it's a var. And yes, that could be let. If you want an instance variable that is set at the beginning and never changes, you can use let. It's pretty rare, but you could do it. Okay? Usually they're var. Display, that's the name. :UI label is the type. Okay? So as you might guess, this has something to do with optionals. Okay? This is kind of confusing to start off the bat. But that exclamation point, which normally means unwrap an optional, obviously we can't unwrap here, we're declaring this thing here. This is pretty much exactly the same as a question mark. In fact, I'm going to change it to a question mark for now, and later I'll change it back to an exclamation point and you'll see the difference. But the type of this display is optional UI label. Now, why is this an optional UI label? Why isn't this just a UI label? Why does it have to be optional? Because when this UI first comes up, iOS needs a few nanoseconds to hook that up for you. So when this UI first comes up, it's not set. It's an optional not set case, and then UI hooks it up for you, and now it's set forever after that. And that's important that it's set forever, and we'll see. That has to do with that exclamation point I just got rid of. But for now, understand that display is just an optional. We'll have to unwrap it every time we use it. Okay, simple as that. All right, so now instead of printing the digit on the screen, let's go ahead and put these digits into the display. And really, every time a digit is pressed, we want to append it onto the end of the display. Like if there's 56 in there, we want to append 2, it's 562, and then 8, it's 5,268, right? So we're just going to keep appending. So we need to get the text that's currently in the display and add the digit to it. So I'm going to have another little local variable. It's a constant also, called text currently in display. And I'm going to get that by sending a message to the display, which I have to unwrap. And now I can send it a message. And here's all the messages that label responds to. Again, hundreds. Okay? So I'm going to do the same trick. I'm just going to type text, because I want the text out of there. Oh, look at the very first one. The text displayed by the label. It's an optional string. Excellent. I'll take it. Okay, so now I've got the text, but it's an optional, so I need to unwrap it. Okay, so now text currently in display, if I option click on it, you'll see it's a string. So now I can just say set the display, unwrapped, text equal to the text that's currently in the display plus the digit. Now notice when I set an optional, text is an optional, right? When I set it equal to something, oh, by the way, this optional you notice is get and set. Unlike CurrentTitle, which was get only. So I can set the labels text here and get it. When I set this optional right here, I don't have to unwrap it first. Okay? So you don't have to unwrap an optional to set it. You just set it, and optionals know, okay, this must be the associated value of an optional string, so I will set it. Okay? So that's it. Let's see if that works. Okay, so we got our UI, looks good. Got a display in there. Let's try 8. Oh, 6. Well, it's kind of working. It's definitely doing the appending thing, but that 0 at the beginning, that's wrong. Okay? That 0 was not part of what I was typing. That 0 just happened to be there at startup, so it shouldn't be put in the front there. And the problem here is really simple. It's just that we haven't taught our calculator to know when the user is entering, in the middle of entering a number, versus when it just started up, or maybe the result of an operation just appeared there. Obviously, when we type, we wouldn't want that to add more things to it. So we need to teach our calculator brain here to know the difference between whether the user is in the middle of typing or not. And we're going to do that by creating another property called user is in the middle of typing. Okay, which is going to be a bool. Now, I typed a long name here, kind of for effect. We probably could have called this typing, but that's a little, you know, there's a trade-off between clarity and brevity. Okay, brevity is valued, but clarity is even more important. So maybe is typing would have been enough, but I would err slightly on the side of clarity. So I'm using this long one. The other reason I type this long is to show you that I'm never going to have to type this again, because Xcode is always going to escape complete this for me, as you'll see when I start using it. Now, when I added this beautiful var, this bool, okay, a bool, by the way, is just something that can be true or false, of course, I got an error. Look at that error up there, this little thing here. And that's on a line that has nothing to do with what I just did. What? That's not fair. What is this? It says class view controller has no initializers. Okay, well, what the heck is that? That has nothing to do with a var either. Well, here's the deal here. Swift, all properties have to be initialized. Every single one. No exceptions. Okay? Now, there's two ways to initialize your properties in a class or a struct. Okay? One is with an initializer. An initializer is a special method. It's called init, I-N-I-T. It can have any number of arguments that your class requires, but in its implementation, it has to initialize all uninitialized properties. Okay? Now, we're not going to talk about initializers today. I'll talk about it a little bit next Wednesday, actually. So we're not going to use an initializer. Because there's a second way to initialize, which is to just give it a value. Okay? Is false, right? The user's obviously not in the middle of typing at the beginning, so is false. And that got rid of the error. Okay? In fact, we don't need this either. Do you see why? Because false can only be a bool. So Swift can infer that this must be a bool. Okay? And again, we do not want these things in here if we can help it. Now, what about this guy? That's not initialized. How come he's not complaining? Okay? How come he's not getting that must be initializers business going on? Well, because he's an optional. And optionals are special when it comes to initialization. They all get this automatic treatment, equals nil. Nil means not set, optional. Okay? That's the only thing nil means in Swift. It means an optional that's not set. So optionals automatically get this treatment at all times when you declare them, and it makes sense, right? If you have an optional, it's going to start out not set until you set it. Now, you could set this equal to some UI label of some sort and have it be set from the start. That's possible too. But if you don't say anything, it gets not set. Okay? All right. So got that. Now we can use this users in the middle of the typing thing. We'll say if the user is in the middle of typing, then we can do this business that we just did here. Okay? What if it's not in the middle of typing? Then we're just going to set the display's text equal to the digit, because we're starting a new number then. Right? In this case, of course, the user is now in the middle of typing. Okay? Everybody got that? So that's just how we're going to make sure we do the right thing. So let's go ahead and run, see if that whole leading zero problem is fixed. Should be, because when we start off, we're not in the middle of typing. So when we start typing a new number, boom, we get a new number. But if we're in the middle of typing, we keep getting the appending deal. Okay? All right, we are just rocking and rolling here. Next, let's put some operation buttons in this baby. Okay? We can type in numbers. Now let's start operating. All right, I'm going to do that by doing a very bad thing, which is I'm going to copy and paste the 7 button. All right? You're going to see why that's bad in a moment. And I'm going to do a very simple operation, pi. Okay? So pi is just an operation that's going to put pi in my display. That's all it's going to do. So I'm going to control drag to wire it up to a method. Okay? It's an action, not an outlet. It's an action, just like touch digit was. I'm going to call it perform operation, because that's what it does. It performs an operation. I'm going to make sure I switch this to button like you guys all are in your homework assignments. And then I'm going to connect. So now I have this new method right here, and it is hooked up to pi. So that's good. And what do I want to do in here? Well, I could do the same thing of asking the button which operation it is, like, oh, how about let mathematical symbol, because that's what these things are on these operation buttons, equal the sender's current title, and exclamation point. Okay, great, now I've got the pi. But I wanted to show you, I promised I'd show you how to do this unwrapping without crashing, so let's do it here. Let's decide that if we do have a blank button, a button whose title is not set, let's say we won't crash, instead we'll just do nothing. We won't do any operation. It's like you didn't even click a button, okay? So again, optionals are so important. You can see, look how minuscule the syntax is for these things, right? Question mark, exclamation point. You barely have to type to use an optional. Well, it's the same thing if you want to test the optional before unwrapping. Instead of putting the exclamation point at the end, you put 2 characters at the beginning, if. Okay? So read this. If I can let mathematical symbol equal the sender's current title, then. Okay? So if I can unwrap this optional, get its associated value, then I'll do something. And then you can just put whatever code you want in here. And inside here, mathematical symbol will be a string, the associated value, the unwrapped optional, right? Outside of these curly braces, mathematical symbol is not even defined. So it doesn't matter. It's not even defined. So inside this mathematical thing, I could say if mathematical symbol equals pi, then do something else if the mathematical symbol equals something else. Okay, but if then else, if then else, if then else, that'd be really bad code. So I'm going to use a different one here, a different little expression. I'm going to use switch. So a lot of languages have switch. So I'm going to switch on the mathematical symbol. Not all languages can switch on a string. Some can, but you can in Swift. And I can just say, in the case that it is pi, then I'm going to do something. Now, unfortunately, I'm getting an error here. So what am I going to do? Let's just put it what I'm going to do. I just want the display, oops, the display's text to equal pi. Okay, this is pretty bad to type it in as a string. We'll get back to that in a second. But that's basically what I want to do, right? Is set the display to be pi. Now, I'm getting an error. What is the error? It says switch has to be exhaustive. And that's true. When you have a switch, you have to have every possible case. So unless we want to spend the next few lectures, I guess going like this, case AAA, and typing in every single possible string, okay, this is no good. So luckily, though, there is a default case. Okay, so default just means all other cases. And here I'm just going to break out of the switch. I'm going to use this command break. Now notice that my indentation's gotten a little messed up here. This should really be the same indentation as this. A really cool feature, select any text you want, even the whole file, and do Control-I for indent. And it'll re-indent everything for you. And I recommend you do that on all your source files when you turn in your homework. Just select all, indent. Okay, so we got this pi here. Let's see if this works. All right, got the numbers are still working, and pi. Oh. Okay, that's weird. I got that pi that I typed in right here. Okay, but how come I got this pi symbol added on there? That seems weird. Let's try a new number. So, oh no. Okay, when I type more numbers, it adds it on to the end. So even if that pi symbol wasn't in there, I'd be able to change the value of pi, evidently, by adding more digits to it. That's no good. Oh, and look at this. When I type more, it puts an ellipsis and stops taking numbers. Okay, this is a mess. So we got 3 big problems here. That pi, the fact that I can add on things to the end of it, and the fact that I get these ellipses. So how are we going to fix those? Let's go fix all three of those real quick, okay? So first, the pi coming on the end. Well, look, where do I ever set the display text? I set it here. So clearly the pi is not coming from this. I set it here. This only sets it to one digit, so that can't be it because I got multiple. This is the only other place I set it. Oh, maybe this is the problem. Do you see the pi button right there? It's hooked up to this method and to this method. So it's doing both. Okay? It's doing this and putting this on here, and then it's calling this and doing this. And the digit is the pi. Okay? So that's bad. Now, how are we going to fix that? Your question? Yeah, the question is, how did it decide the order? And the answer is the order is undefined. In my experience, it's usually alphabetical, but it's undefined, so you would never want to depend on that. But yeah, perform comes before touch digit. I don't know. But you're almost never going to have two things hooked up like this. This is obviously an error. This is causing a problem. So let's fix it. How do we do that? There's another way to know what's connected other than using these little circles, which is just to right-click on something in the UI. So I right-clicked on pi, and I got this big window that shows me all the connections to pi. This would be all the instance variables, all the methods, etc. And we can see that for the event touch up inside, which means a touch of the finger went up inside the bounds of the button, it's sending both these messages, touch digit and perform operation. And we clearly did not want touch digit for pi. Why did I get it? Because I copied and pasted that 7. Remember I said that was a bad idea? Yeah, that's why. So let's disconnect it by just clicking this little X. Okay, boom. Now this only is sent by this and not by this. So that fixed that. What about the fact that I could type extra numbers on the end of pi? Well, that's a pretty simple one either. When am I allowed to type other numbers in? When the user's in the middle of typing a number. Well, as soon as I hit pi, is the user in the middle of typing a number? No. They just typed pi, so they're not in the middle of typing pi. And in fact, typing a number. And in fact, anytime we perform any operation, the user is in the middle of typing a number is false. They are clearly not in the middle of typing anymore. Whatever's in the display is going to be the result of that operation. Okay? So that fixes that. How about the little ellipses and the numbers getting cut off? Well, here's a kind of a cute fix to that. In label, there's a cool feature called auto shrink. You see it right there? So I just selected label, brought up this inspector. There's auto shrink. And you can have it shrink down, for example, to a minimum font size, let's say 9-point font. And now, when we get too many numbers, it'll shrink down instead of just doing ellipses right there. Now, this probably isn't the best solution to this. A better solution would be have our calculator only show a certain number of digits after the decimal point. That would be really better. And that's extra credit for you and your homework, okay? So good luck with that. Right, so we got this. We fixed all these problems. Let's take a look. All right, so got our numbers here. Pi, all right, no pi. And it didn't add them onto the end. And what if we have a lot of numbers in here? Oh yeah, look at that, it's auto shrinking. Okay, we're not losing any numbers. Again, probably not the best solution, but I get to show you auto shrink. Okay, what's next? We're going to attack this little problem right here. Okay, this is really ugly. Really, what I want this to be is this really cool feature in Swift, double.pi, which is the double precision floating point value of pi. Of course, I can't say this because cannot assign value of type double to an optional string, because the only way you can assign anything to an optional string besides nil would be something that's a string, so we can set that associated value. Now, does anyone know from what I've shown you today how we could convert this to a string? No brave soul? Exactly. Backslash, open parentheses, close parentheses, that little trick, right? We can just put double.pi in here. Doubles can be converted to strings. Bingo. Now, this is kind of ugly. Okay, this really doesn't look good because this is more meant to embed things in other strings. It's not really the way to make something a string. The way to really make a new string is to create a new string. And so here you're seeing what the syntax is to create a new object, a new struct or a new class. Okay, you just the name of the class and then parentheses. Now, inside these parentheses can be anything the class can take to create one of itself. Right? Anything that class can take. And remember I mentioned those initializers? These are the arguments to the initializers. And initializers, you can have multiple initializers. String has a whole bunch of initializers. One of the initializers that a string has takes a double. So this would be the right way to convert from a double to a string. And it looks a lot better in the code as well. Right? It's more obvious what we're doing here. Okay? All right, let's add another operation here. I'm going to make this one be square root. So I'm going to get the square root symbol from the edit menu, emoji and symbols. You can actually search. We could make it smiley face, but let's go square root. Square root. Oh, here it is. So we're going to use the square root symbol in Unicode there. And let's go ahead and copy it so we can use it in the code. All right, so we have this. It's nicely hooked up just to this and not to this, so that's good. We just need to say case of square root. What do we want to do? We want to set the display's text equal to the square root of something. Okay, well, what do we want this to be the square root of? Well, we want it to be the square root of what's over in this display already. So, display.text. Okay, will that work? No, because this is a string. We can't take the square root of a string. And not only that, but square root returns a string, returns a double. Okay, and we can't put a double into a string, so we at least have to do this again, put a string around it. Okay, but this is still a string, so I'm going to get this out of here and make a little local variable so we can work on this. Okay, so we need this operand, which is currently a string, to be a double. So can we do this? Double? Do you think we can do that? In the same way that we went this way, can we go this way? And the answer is yes, or yes, one of those. The answer is yes, because what if that string is hello? What do you convert hello to? It can't be converted. So this initializer for double that takes a string, it returns an optional double. Do you see why? Because if you give it a string that it can't convert to a double, it returns not set. Couldn't do it, basically. So if we look at operand right here, it's an optional double. Okay? Whereas when we did this string up here, string didn't need to return an optional string because it can always convert a double to a string, always. But you can't always convert a string to a double. It has to look like a double. Okay? So we're going to do that, and I'm going to go ahead and force unwrap it here with the exclamation point, assuming that I never have anything in my display that can't be converted to a double. Okay? Maybe that's a bad assumption, but I'm going to assume that for now. I'm also going to control I again, get my indenting right. Okay? Does this make sense? So now all is well. Operand is a double, so I can take the square root of a double. I'm going to convert it to a string and go to here. All right, wow, that's a lot of mess. Okay, that's a really messy code. We're going to have to fix that. But conceptually, you understand hopefully what's going on there. So let's do this. Let's try 81 square root. Square root again. Square root again. How about pi square root? 78 square root. All right, this is working perfectly. But our code is really a mess here. Can you imagine if we have to do another case, and we're always doing this double this, string that, back and forth, exclamation points everywhere? Okay, there's too many dang exclamation points in here for the first thing. And then second of all, I'm tired of all these strings and doubles. So how am I going to fix all that? Let's start with the exclamation point thing. Look at every time I use the display. I use it all over my code. And every time I have to put an exclamation point. Every single time. Even though I know that display, once it's set up by iOS at the beginning, it never is not in the not set state. It's always set. So let's go back up here to this question mark. This is what exclamation point in a declaration of an optional means. It means, yes, this is an optional, just like a question mark, but everywhere you use this, I'm going to automatically unwrap it. Now, it's still unwrapping it. So even if I go down here and I take away this exclamation point, it works because of this automatic unwrapping. But if this were not set, it would still crash. Okay? Because it's essentially implicitly unwrapping. That's why this is called an implicitly unwrapped optional. Got that phrase? Implicitly unwrapped optional. Okay? But it does mean that we can go around to all of our display question marks and change them to display. And that makes our code look quite a bit nicer. Okay? Now we're still having to unwrap the text. Sorry about that. Okay? Bottom line is we have to do that. That's not an implicitly unwrapped optional, that text. Okay, what about all this double and string thing? You know, the way I'm going to fix that is, imagine I had a var, I'll call it display value, and it was a double. Okay, so I have this var. Imagine if this var always tracked what's in here, but as a double. Because what's in there, we can only get it as a string. We can only set it as a string. But wouldn't it be cool if I had a var that just was always what was in there, but as a double? Because I need it as a double all the dang time, and I need to set it as a double too. Okay? So how can I do that? Well, turns out Swift has a really cool feature called computed properties. And all you need to do is put code after the property, and you can compute the value instead of storing it. Right? User is in the middle of typing a value that's stored somewhere. This one we're going to compute. And you can compute both a get case, right, and, and a set case. Okay? So you can have some code that deals with getting the value and with setting the value. So we're not going to ever store display value anywhere. We're going to get it and set it. And where are we going to get it and set it from? From the text on the label. Right? So what does the get look like? Well, we're just going to return a double of the display's text. I don't have to unwrap display, but I do have to unwrap text. And I'm going to force unwrap that. Again, I'm assuming there's always a double, a string that's that can be interpreted as a double in there. Yeah, maybe I want to change that assumption down the road, but for now I'll do that. How about the set case? In the set case, I want to set the display's text equal to a string that is the value the people are trying to set the display value to. So somewhere in the code, we write display value equals 5. And here, we have to put a 5, a string 5, into the text of the display up here. So what do we put inside this little string here? Well, for this set case, okay, of a computer property, there's a special variable called new value. And new value is always of the same type as what you're setting, and it is the value on the right-hand side of an equals if someone says that this var equals something. Okay? Awesome. Now that we have this display value and it's always tracking that, we can use it down here. Look at this code. Display value equals pi. Done. Get rid of all this mess. Display value equals the square root of the display value. Okay? All of a sudden, the code down here has become essential, right? This is about the minimum you could possibly type to say that you wanted pi into the display, right? And so when I do this display value equals, this code gets executed. When I get the display value here, this code gets executed. Okay, these are called computed properties. You're going to see them all over the place. You've already seen one. It's right here. CurrentTitle is a computed property. It's computed by the button class. It figures out what the current title is on there and returns it. So this is implemented with some code that says return whatever. How do I know that? Because it's read-only. The only way to make a read-only var is using a computed property. All right, let's make sure we didn't break anything with our code cleanup there. All right, 89, looking good, square root. 81, square root, square root, square root. Pi, 7, 8, square root. Okay, it's working. Okay, so that's a lot of stuff to digest, I know. Let it all sink in. On Wednesday at the start, I'm going to talk to you about MVC, this design paradigm, and then we're going to add MVC to this, and we're also going to make it so that UI works on all devices. Okay, see you then.
For more, please visit us at stanford.edu.